In this video, we're going to study cardinality of union of two or three sets. Okay, first we recall the definition of cardinality. So we know that cardinality refers to the number of elements in a given set. Now, based on these two Venn diagrams, we are going to determine the cardinality of the union of two or cardinality of the union of three sets. First, let's determine the cardinality of set A. So we recall the symbol for cardinality is N, then parenthesis A. So this means cardinality of set A is equal to, okay, so to determine the cardinality of set A, let's count the elements that belongs to set A. So here, circle, the first circle. So let's count the elements 1, 2, 3, 4, 5. So there are 5 elements. What about the cardinality of set B and a B? Let's count the elements 1, 2, 3, 4, 5. There are also 5 elements. Now this time, let's determine the cardinality of A union B. Okay, so A union B refers to the elements that belongs to A or B. So everything that is inside the circles A and B are elements of the union of set A and set B. So let's count all these elements that belongs to these three regions, S sub 1, S sub 2, and S sub 3. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now observe that we have cardinality of A, which is 5, and cardinality of B, which is 5. And the cardinality of the union of set A and set B is 8. Why is it that it's not 10? Now think of it. Okay, so the reason for this is that because of the cardinality of the intersection. So observe that when we count for the cardinality of set A, we counted the cardinality of the intersection. And also, when we count the cardinality of set B, we also counted the cardinality of the intersection. So this would mean that the cardinality of the intersection is counted twice. So to erase or to get rid of this error, we need to subtract the cardinality of we need to subtract one count of the cardinality of the intersection because it's counted twice. So therefore we have the formula for the cardinality of A union B. Cardinality of A union B is equal to the cardinality of set A plus the cardinality of set B minus the cardinality of A intersection B. Okay, so to use this formula, we need to find first the cardinality of the cardinality of A intersection B. Okay, so let's determine the cardinality of A intersection B. So how many elements are there belongs to the intersection of set A and set B? So we have these two elements, 4 and 5, so therefore there are only 2 elements. So we have the cardinalities of A intersection B is equal to 2. Now let's use the formula to find the cardinality of A union B, which is 8. Let's see if we can get 8. Now we know that the cardinality of set A is 5 plus the cardinality of set B is 5 minus the cardinality of A intersection B is equal to 2. So we have 5 plus 5 is 10 minus 2. The answer is 8. So we find the answer or the cardinality of A union B. Okay, so this time let's move on the cardinality of the union of three sets. So what is this first? Okay, so first let's list the cardinality of set A. What are they? How many elements are there in set A? Let's count 1, 2, 3, 4, 5, 6. Cardinality of set B. 1, 2, 3, 4, 5, 6 also. And cardinality of set C. 1, 2, 3, 4, 5, 6. All 6. Now let's determine the cardinality of A union B union C. Let's count the elements that are inside the regions of the union of the three sets in the Venn diagram. So we have how many regions are there? 1, 2, 3, 4, 5, 6, 7 regions. And let's determine the element. Let's count the elements that belongs to these regions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11. Okay, so now why is it that the cardinality of the union of the three sets is not 3 times 6 or 6 plus 6 plus 6, which is 18? Why? Okay, so observe and study the Venn diagram. Okay, so this is because of the intersection. Okay, okay. So observe carefully. We need to subtract, right? We need to subtract cardinalities of the intersection so that we could arrive at 11. So how is this done? Okay. Now try subtracting the cardinality of the intersection. Okay, the intersection of set A and set B, because this will be counted twice, right? So you need to subtract one intersection. Another, you need to subtract uh, cardinality of the intersection of set A and set C, because this will again be counted twice, so you need to subtract one count. And another is the cardinality of intersection of set B and set C, because this will again be counted twice, so you need to subtract one count. But observe that when you subtract the three counts of the intersections of A intersection A intersection C, and B intersection C, now the cardinality of the this region here, A intersection B intersection C, will become zero or will be eliminated. So therefore, you need to add this again so that you could result to accurate cardinality of the union. So therefore let's now determine the formula and let's apply this. Let's see if we can get 11. We can get the correct cardinality. So we have now the formula for the union of three sets. Cardinality of A union B union C is equal to the cardinality of set A plus the cardinality of set B plus the cardinality of set C minus cardinality of A intersection B minus cardinality of B intersection C minus the cardinality of A intersection C plus the cardinality of A intersection B intersection C. Okay, let's see if we can get 11. But we need information first about cardinality of the intersections here in the formula: A intersection B, B intersection C, A intersection C, and the intersection of the three sets. So let's continue with writing our given cardinalities. So we have cardinality of A intersection B. So how many are there? How many cardinalities are there in the intersection of set A and set B. So we have these two regions. So let's count 1, 2. There are only two. Cardinality of B intersection C. Okay, these two regions. Let's count 1, 2, 3. There are three elements. Cardinality of A intersection C. Let's count 1, 2, 3. A intersection C. There are three elements. So cardinality is 3. What about the cardinality of A intersection B intersection C? So how many elements are there in the intersection of the three sets? These regions, there is only one element. We have F. So therefore the cardinality is 1 for the intersection of the three sets. Now let's substitute these cardinalities in the formula. Let's apply the formula if we can get 11. So we have cardinality of set A, so we know that it is 6, plus cardinality of set B is 6 also, plus cardinality of set C, which is 6 also, minus cardinality of A intersection B is 2, minus B intersection C is 3, minus the cardinality of A intersection C is equal to 3, plus cardinality of A intersection B intersection C, which is 1. Okay, so let's add and subtract the cardinalities. So we have 6 plus 6 plus 6 is 18, minus 2 minus 3 minus 3 plus 1 equals 18 minus 2 is 16, minus 3 minus 3 plus 1. We have 16 minus 3 is 13, minus 3 is 10, plus 1 equals 11. So here we have determined correctly the cardinality of the intersection of the three sets using our formula. Now let's have examples applying the formula without a Venn diagram by just using the given cardinalities of the given sets. But let's have more space, so let's erase everything here. Okay, suppose for example, okay, we have set A with the elements of the letter of the alphabet A, C, and D, and we have set B containing the elements A, B, D, E, F. Okay. Okay, let's find the cardinality of A union B using our formula. So it's really very important to memorize the formula so that we can apply this in solving word problems involving sets. It's very important. So you have to memorize the formula. Okay, so what is the formula for the cardinality of the union of two sets? So we have cardinality of A union B is equal to cardinality of A plus the cardinality of B minus cardinality of A intersection B. Okay, so to find the cardinality of the union, so therefore we need informations about the cardinalities in our formula. So let's determine the cardinality of set A. Okay, so by counting the number of elements in set A. So there are three elements for set A. Cardinality of B, we have how many elements in set B? 1, 2, 3, 4, 5. So we have 5 elements. And let's determine the number of elements for A intersection B. Okay, and so to determine the cardinality of A intersection B, we need to know the elements of the intersection of sets A and set B. So we have common elements A and what else? D. So therefore, Therefore, how many elements are there in the intersection? There are two. We have the A and D. So A intersection B, cardinality is equal to 2. Okay, so let's continue. We can now apply the formula by substituting the given cardinalities. We have cardinality of A is 3 plus cardinality of B is 5 minus cardinality of A intersection B is 2. 3 plus 5 is 8 minus 2 is equal to 6. So therefore, the cardinality of A union B is equal to 6. Now let's check if our our answer or the cardinality of A union B is equal to 6 by finding uh, the elements of A union B, and then let's find the cardinality afterwards. So let's list the elements of A union B. So first, let's list the elements of A. We have A, C, D, and then let's list the elements of B. Okay, we have A, so we are not going to write A anymore since we have listed it already. A, then B, D, so we have already D, then E, and then F. So these are all the elements of A union B, A, C, D, B, E, F. And let's determine the cardinality of A union B by simply counting. We have 1, 2, 3, 4, 5, 6. Okay, so we have get it correctly. Okay, let's try finding the cardinality of union of three sets without a Venn diagram. Okay, let's erase everything here first. Okay, suppose we have set A containing the elements 0, 2, 4, 5, 7. Set B containing the elements 1, 2, 3, 4, 6, 8, and 9. And set C containing the elements 0, 2, 3, 4, 5, 6, 9, and 10. Okay, let's determine the cardinality of A union B union C. Okay, let's recall the formula. Formula is very important. So we know that the formula is, we have cardinality of set A plus cardinality of set B plus cardinality of set C minus the cardinality of A intersection B minus the cardinality of B intersection C minus the cardinality of A intersection C plus the cardinality of A intersection B intersection C. Okay, so we need to know the informations about these cardinalities in our formula. So let's determine the cardinality of set A first. So how many elements are there in set A? 1, 2, 3, 4, 5. 5. Cardinality of set B. 1, 2, 3, 4, 5, 6, 7. Cardinality of set C. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8. How about the cardinality of A intersection B? What are the common elements of A intersection B? So we have here 2 and 4. So therefore there are only 2. Cardinality of B intersection C. How many elements? We have 1 common elements. 1, 2, 3, 4, 5. Okay. B intersection C has 5 elements. So cardinality therefore is 5. How about the cardinality of A intersection C? A intersection C, we have 0, comma, so 1, 2, 3, 4. Okay, so there are 4. How about the cardinality of A intersection B intersection C? So the common elements of the three sets. Let's see if there are common elements of the three sets. So we have here, okay, 1. The element 2 is common to the three sets, so 1. And element 4 also, 2. Okay. There are only 2 common elements for the intersection of the three sets. So cardinality, therefore of the intersection of the three sets is 2. So we can now apply the formula. So cardinality of set A is 5 plus set B is 7 plus set C is 8 minus 2 minus 5 minus 4 then plus 2. Okay, let's add. So 5 plus 7 is 12 plus 8 is 20. And minus 2 minus 5 minus 4 plus 2. 20 minus 2 is 18. 18 minus 5 is 13. 13 minus 4 is 9. 9 plus 2 is 11. So, therefore, the cardinality of A union B union C is equal to 11. Now, let's see if our answer using the formula is correct. Let's determine first the cardinality of the union of the three sets. Okay, so first we list the elements of set A 0, 2, 4, 5, 7. And then next we will list the elements of set B which are not in A to avoid repetition of elements. So we have 1, and then we have 3, and then we have 6, and then we have 8, and then 9. Okay, this time we will list the elements of set C that are not found in A or B. So 0, we have listed already 0, 2, we have listed it already, 3, 4, 5, 6, and 9. And let's add one last element, 10. Okay, now let's determine the cardinality of A union B union C by counting the elements. Let's see if we can get 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, perfect.